All right, hey everybody. Today we're going to talk about, or tonight, we're going to talk about another way of displaying data information. We've learned about things like dot plots, bar graphs, and histograms. So now we're going to take it one step further. We're going to learn about one more way of showing data, displaying it, called the box and whisker plot. And I like these a lot, and one of the things I really like about them is they show a lot of information in a very easy way for people to understand and visualize. So that's a great thing about it. And the other thing that I think is really cool is we tend to think of math as something that's kind of just been around forever and nothing ever changes, and it's been around for hundreds of years or thousands of years, and it's exactly the same as it's always been. But box and whisker plots have only been around since like the late 60s. So it's something that's relatively new, and in math terms, it's really new. So maybe there's something that we can do, you could do someday, that will be this new way or way of looking at math, or this new construct that you came up with yourself, and people will start to use. So we'll get into it. Right now I have a set of data. I have a number of quiz scores here. And we're going to take a look at a box plot. So to show you what one looks like really quickly, here are a couple of them. We're going to get back to that in a little bit. But what we're going to try to do is we've got to find 5 pieces of information. So sometimes a box and whisker plot is called a 5-point plot. All right? And I've already arranged these 10 quiz scores in order from least to greatest. And I want to find the minimum value. So we know that that's a 47. The maximum value is 95. So I always want to find the smallest and largest values first. All right. Then we need 3 other numbers. We're going to need the median, and we've talked about median before. So it's the number that's going to split the data in half from least to greatest. So with 10 numbers, as I count my way in, I think it's going to be, if you check, it's halfway between the 77 and 79 there. It's an even number of data points, so I need the middle 2 numbers, and the midpoint between 77 and 79 is 78. So our median is going to be 78. And then the other 2 numbers, the Q1 and Q3, we call those the first quartile and the third quartile values. And quartiles, because they have that prefix quart, or that root in there, quart, means 4. So this is going to split the data up into 4 parts. All right. So what I'm going to do is I'm going to find for each half of the data. So here's my first half and second half. I'm going to find the median for each half. And each half has 5 values, so it's not too bad. The median for these 5 is a 73. So the first quartile, also called the lower quartile, right, is 73. So the median for the lower half of the points. Right? Then the median for the upper half of the points is what we call the third quartile. So if I look at these 5, the middle number is 89. So that's the third quartile, the upper quartile, and I get an 89. All right. Now, to make my plot, I'm going to make a number line, and now I know what my scale is going to be, my range of numbers. Right, so I'm going to go from 47 to 95. So I'm going to start at 40. I'm going to put a title at the top, quiz scores. And we're going to go up to 100. So 50, 60, 70, 80, 90, and 100. And it's just like any graph. When we start to make an axis, we want these points to be the same distance apart. We want their intervals to be consistent. So these numbers are not these numbers. I'm just trying to find a scale that works, that's consistent, and is going to include all these numbers at the top. All right. And then what I'm going to do is I'm going to plot those 5 points. The minimum, 47. It's around there. My quartile 1 is 73. My median is 78. The upper quartile, the third one, is 89, so a little before 90. And my maximum value is 95. All right, so I've got 5 points. There's that 5-point plot that I kind of alluded to before. And then to make my box and whiskers, here's what I'm going to do. I'm going to take my Q1, my Q3 values, my first and third, so those middle 3 points, I'm going to put a rectangle around them. I'm going to put a line through the median, so there's the box part, and then I'm going to just draw lines or segments from the box out to the endpoints, and those are the whiskers. All right. So I can get some information out of this. This is a great visual. So I can see where the median is. I can see where the quartiles are. I can see the min and max. Sometimes when there are outlier values that are really extreme, like the 47 is kind of extreme, sometimes those aren't included. They might just draw the whiskers out to the next lowest point, and then any outliers they might just put dots and don't have the line going out to them. All right. One of the cool things about this is now what we see is, on the average, 25% of the data points are in that first whisker, 25% of the data points are in that first half of the box, 25% of the data points are in that second half of the box, and 25% of the points are in that upper whisker. And then you can see how spread out the numbers are. So if you make a rectangle that's really small and narrow, that means a lot of numbers are clustered around the middle. If you have like a really wide rectangle, a really wide box, then that means that those middle half of the points are spread out. All right, so it gives you an idea of how spread out points are. I can see there's a pretty good spread here in that lower 25%, so that was kind of a clue that this was sort of an outlier. It was really different from most of the other scores. And there's a cluster of points that are close to each other around that upper 25%. All right, so that's how you build a box and whisker plot. And then what we're going to do is we're going to answer a couple questions. We're going to look at a couple and just draw some conclusions from them. So here is one. All right, these are the ages of Oscar-winning actors over a 30-year period, 1975 to 2004, between females and males. And the box and whisker plot, so I noticed there's a bigger spread among the males, right? So especially that middle 50%. So it seems like there's a bigger spread here, and most of the women, at least half of that middle half of the women, most of them are in their early 30s to early 40s. So it's not a huge gap, but the middle 50% of males are from maybe their late 30s, maybe like 37 or so, out to over the 50s. So there's a wider gap or a wider variance among them. The length of all of them are pretty much the same. So they seem to have the same amount of spread. We do notice that there are 3 outlier points here among the women, and 1 outlier point among the men. So a lot of the men are in that box and whisker plot, and then a few of the women are not. But you notice, here's we start learning some conclusions about this. So I noticed that the males seem to be farther to the right, and their ages of Oscar winners tends to be older than for females. So that is one thing that people say, that female actors or actresses have a hard time getting jobs, have a hard time getting work as they get older, and then have less opportunities to win awards. So we can kind of see that here in this plot. And if I just saw a list of numbers of Oscar winners, it might be hard for me to deduce that. But this visual tends to make it clearer that women actresses tend to win their Oscars when they're younger than males, and males seem to get more opportunities for lead roles as they get older. So that is how we work with box and whisker plots in a nutshell. Hope this helped, and we can always watch this again, or if you have any questions, I'd be glad to help you out. All right, so thank you, and have a good night.